Hi.
Hi everyone, that is Flo. I'm the CEO of the OpenHW Group, Canada-based, Ontario, globally acting non-profit. What we are doing? RISC-V, industrial grade RISC-V. Wait, it's getting better. Industrial grade, fully open source, fully verified, fully documented RISC-V. Apache 2.0 license. You go to our GitHub, you download it, including the verification suite, you make your own chip, you make a product, fully fine. And if you love it, you come, you become a member of us, you're supporting us, you work with all the other members like Silicon Labs, Cyrus, Thales, Accelera, you name them. Worldwide, we have the members who are working together to verify this IP, to make this RISC-V open source and usable, industrial grade ICs.
So what is your positioning in the RISC-V ecosystem? How do you fit in?
Very good question. So the RISC-V itself, RISC-V International, that's the specification, but then below you have a lot of vendors who are offering RISC-V. Here in Taiwan, Computex 2024, Taiwan has Andes Technology, commercial RISC-V. In America we have Sci-Fi, we have CodaSip in Europe who is RISC-V. CodaSip, by the way, is also a member of OpenHW. And then OpenHW, we are one of the only fully open source, fully commercial one. So we really aim that you can take our RISC-V IP, you put it in an IC, and you make an IC you're shipping in the millions. For example, one of our cores, the CVE40, that core is shipped over 500 million times. It's a real product, and you can get it. You can get the open source, you can put it in your thing. CVA6, it's a Linux-ready core. Think about setup boxes. That's where this core is going in, comparatively like an ARM A53, A55.
In mass production?
That one is not yet in mass production, so we are preparing this together with our partners, with our members in Europe, but also in America and here in Asia, and it will be in mass production relatively soon, I believe.
Did you say 500 million?
We have 500 million shipments of this E40 cores.
What is the performance of that core?
That core is roughly like an ARM M4. But now the thing is, we only know because people tell us. They come and say, hey Flo, we have shipped 100 millions of your core in a commercial product. Cool. Others come and say, Flo, we have shipped 200 million. The point is, because it's open source, it's Apache 2.0 license, you don't need to tell us. So 500 million, we know we have shipped for sure. Maybe it's much more.
And there's no license?
There is no license, it's Apache 2.0, it's no royalty, and you just get it. The only thing we are hoping is that if it's helpful for you, you join the OpenHW as a member, you get a free flyer, a free sticker, but you also get the connections to all the other OpenHW members. So imagine you're joining us, it's a big community. You can develop this RISC-V CPU IP together with companies like Cirrus Logic, with Silicon Labs, with Thales, with Accelera, CodaSip. There are so many members who are just joining and working together on a neutral ground, developing the RISC-V CPU IP, the core, and then making their own products and putting it inside.
What is this?
That is actually what we are offering. You see, the main thing is really the core. We have three families, CVE2, super deeply embedded, CVE4, like an ARM M4, let's go back one, and then CVA6, that's for setup boxes like A53, 55. The core is what we are offering, the verification to make sure there is no bug inside. We also give you fully open source. Then we have the documentation, but our partners like Embacosm in UK, they work on the compilers, LLVM, GCC, fully open source. Not only Embacosm, also BOSC, Beijing Institute of Open Source, helping with the compilers. Amazon working on the FreeRTOS, for example. Red Hat working on the Linux. So we really get everything here in the OpenHW, and we are making it open source.
Oh, that's next gen, because that's the chip that comes out later, right?
That is what comes out later, but you need to prepare it now. You need to get ready to have it when the chips are ready, and that's why Red Hat joined OpenHW as a member and working on it.
Or?
Yes, actually it's super cool. We are working on the FPGAs in the Amazon data center. So we make a Linux-capable system, you can spin it up on an Amazon instance with the FPGA instances. You get super high performance, and you can port your apps on RISC-V. That's what Red Hat is doing. That's where Red Hat supports us.
Nice. Right. So actually, RISC-V is actually shipping in a lot of stuff.
It's in a lot of stuff. Look, for example, on a smartphone. I like this example. You have a touch to do things. So the touch, RISC-V. You have a Wi-Fi to connect to your network, RISC-V. You have a storage to store all your cute, precious pictures of your cat. The storage, RISC-V. So RISC-V is basically everywhere except for the main processor. And the main processor, we're on the way to go there. Our good friends over at Qualcomm, Daileo, hey, if you hear me, they are working on this together with our friends from Google. Hey, Lars Bergström, they are really amazing. So we will have Android on RISC-V very soon, and then it's just a matter of time until we have fully RISC-V powered phones.
Which phone is that?
That's a Google phone.
And
I'm not sure if Google is using it. I know from the Chinese manufacturers like Oppo and so on, they have RISC-V inside. They are not doing it on purpose. They are buying like the NAND flash from Phison in Taiwan. There is RISC-V inside. They buy the touch controller from Taiwan, Infinix and so on. There is RISC-V inside. That's how I know it. So Google, I don't know what they are using honestly, but in general, it's the example where RISC-V is already today.
But those different microcontrollers have examples that could be RISC-V, but not necessarily all of them implemented in the phone yet, right? It could, might be.
They are already. So it depends really which vendor you have. A lot of them have RISC-V already inside.
And some of the stuff you do goes in phones?
Yes, some of the stuff we're doing goes in phones. It goes into Wi-Fi chips. So Bluetooth, Wi-Fi, Zigbee servers is our RISC-V controllers already inside, and that's also part of the volume shipment where we are coming from.
And what's the RTOS, or kind of like the software that runs on these little microcontrollers?
It's a variety. So some people still use bare metal. There is more and more for real-time operating systems. So Amazon with the FreeRTOS, HeyJoe, they are supporting us a lot. Then we have Zephyr, of course. Zephyr is more coming. We have ThreadX, where I will be speaking later this week. They are really pushing also for RISC-V. Hey, Cassie, if you're listening. And then you're also going to the more high performance, where you have Linux Yocto, where you have Red Hat Fedora projects working on it. And there is a variety like Canonical with the Ubuntu, but also SUSE and Debian. They all work on RISC-V for high-end, and in the low-end, for the phones, for the Wi-Fi, FreeRTOS, Zephyr, things like that.